to Agora Math Circle. Before you continue watching this video, make sure to subscribe to the Agora Math Circle channel. This is Junior Intermediate, and we're going to be learning about the order of operations. Wait, what is the order of operations?
Well, that's easy. The order of operations are basically a set of math rules that tells you which math operation you should use first. And an operator is a mathematical symbol for an expression. Well, here's an example to let you understand. An operation are basically addition, subtraction, multiplication, and division. And the operator is the symbol that you use in each of the operations. So for example, in addition, you use the plus sign. In subtraction, you use the minus sign. And in multiplication, you use the x. And division, you use the sign. So here's an example of all these operations. So an example of addition is 2 plus 4. It's basically when the first number increases from the second number. So 2 increases 4. So 2 plus 4 is 6. So subtraction, which is this sign, is an example of 4 minus 2. This is where the first number decreases from the second number. So 4 decreases 2 points. So we get 4 minus 2. And in multiplication, this is basically repeated addition of the first number from the second number. So it's 2 times 4. So we're basically adding 2 to itself 4 times. And in division, it's repeated subtraction from the second number to the first number. So it's 8 divided by 4. So you're basically splitting 8 into 4 groups. And this operation is known as arithmetic.
And in order of operations, we mainly use arithmetic operations. And today, we're only going to be focusing on arithmetic operations. So, some of you must wonder why we need order of operations. Well, let's find out through this word problem. Sarah purchases 2 pounds of rice for $1 a pound, 2 loaves of bread for $3 a loaf, and a chocolate for $10. How much change should she get if she gives the cashier $20? Now, using this information, let's try to come up with an equation. So 20 minus, since we're subtracting the total cost from 20, minus 2 times 1, since she purchases 2 pounds of rice for $1 each. And 3 times 2, since she purchases 2 loaves of bread for $3 a loaf. Plus $10, since she purchases a candy for $10. Now, if we weren't using PEMDAS, let's just solve normally left to right. So 20 minus 2 is 18. 18 times 1 is 18. 18 plus 3 is 21. 21 plus times 2 is 42. And 42 plus 10 is 52. So we would get 52. Now, does 52 make sense? So does it make sense that she gives the cashier $20 and gets 52 back? No. So we have to use PEMDAS. PEMDAS stands for parentheses, exponents, multiplication, division, addition, and subtraction. All of these are operations. So it's basically the order of operations that we use in word problems and just basic equations. So let's use PEMDAS. So 20 stays the same, but we have to put 2 times 1 in parentheses since that is what she purchases. Plus 3 times 2 also in parentheses. And 10 can stay the same. Now, according to PEMDAS, we have to solve for the parentheses first. So let's solve. 2 times 1 is 2. 3 times 2 is 6. And 10 just stays the same. Now, since we're subtracting total cost from 20, we have to put a parentheses around here, or else we would get different answers. Now, 2 plus 6 plus 10 is equal to, well, 2 plus 6 is 8, and 8 plus 10 is 18. So we're basically solving for 20 minus 18. Now 20 minus 18 is 2. So Sarah gets $2 back. So now you know about PEMDAS.
Now that we've learned how to solve using order of operations, or PEMDAS, let's get into what PEMDAS really is. Well, we know that PEMDAS stands for parentheses, exponents, multiplication, division, addition, and subtraction. Now, if you've noticed on the board, I wrote that parentheses is not really an operation. This is because parentheses is used to encapsulate a set of numbers and operations, which means that it's used to group together a set of numbers. So, now let's go ahead and solve this equation. Well, as you can see here, the parentheses is used to group these two numbers together and these two numbers together. Now let's go ahead and solve this equation using PEMDAS. So, first on our list is parentheses. Do we see any parentheses here? Well, yes, we see 2. So we first have to solve 5 plus 2, which is 7. And we have to leave the rest the same because we're only solving for the parentheses here. And 4 divided by 2 is 2. And we're going to leave it the way it is. Now, let's see over here. Do we have any exponents? Well, if we look, we don't have any exponents. So the next thing on our list is multiplication. Now, we do have multiplication over here. So we have 7 times 3 is 21. And again, we're going to leave everything the same because there's nothing else to multiply. So we get 21 plus 2 minus 5 plus 2. Now we move on to addition or subtraction. And I just want to say that addition and subtraction can be switched around. It's either subtraction and addition or addition and then subtraction. Now in this case, next on our list is still addition. So we get 21 plus 2, which is 23. And 23 minus 5 is 18. And 18 plus 2 is 20. Now I'm going to write that down. Well, we get 21 plus 2 is 23 minus 5 plus 2. Then we get 23 minus 5, which is 18. 18 plus 2. And we know that 18 plus 2 is equal to 20. Therefore, 20 is the right answer. Now let's learn a little bit more about exponents and what they really are. So, exponents is an operation representing the number of times a number is multiplied to itself. It can be said or written as one number to the power of another. So, an example would be 3 to the power of 3. So, we know that when we solve equations, we're basically solving the number of times this number over here is multiplied to itself. And we can find out how many times a number has to be multiplied to itself by looking at the number at the right corner of the digit. So in this case, which is 2 to the power of 4, 2 has to be multiplied to itself 4 times, since the number on the right corner is 4. So let's go ahead and solve these equations. Well, we know that 3 has to be multiplied to itself 3 times. So let's go ahead and write that. So we get 3 times 3 times 3. That's 3 times. And we get 3 times 3 times 3, which is 3 times 3 is 9, and 9 times 3 is 27. So the answer is 27. So we get 27. So now that you guys have an idea on how to do one over here, go ahead and pause the video and try this example. We can solve it together. So now let's go ahead and solve this example over here, which is 2 to the power of 4. And we know that it means 2 has to be multiplied to itself 4 times. So let's go ahead and write that down. We get 2 times 2 times 2 times 2. That's 4 times. And while doing that, we get 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And I also want to add in 2 more important parts. And so I'm going to use a variable such as x as an example for a number. X to the power of 0 is always going to be 1, so remember that. And x to the power of 1 is still going to be the same number. It's not going to be multiplied by anything, it's just going to remain x. So an example would be 5. So say we're doing 5 to the power of 0. 5 to the power of 0 would be 1. and 5 to the power of 1, since it's going to stay the same, would just be 5. So now that we've learned all these important parts, let's go ahead and try to solve all of PEMDAS. So in this equation, we're going to have parentheses, exponents, multiplication, division, addition, and subtraction. So let's go ahead and solve. So our problem is 5 times 2 times 3 squared, or 3 to the power of 2, times 3 plus 4 divided by 2 times 5 squared, or 5 to the power of 2, minus 5 plus 2. So first on our list is parentheses. So let's go ahead and solve the two parentheses we have over here. And this is supposed to be a plus sign. So we get 5 plus 2. So that's 7 times 3 squared. We're just going to leave everything else the same. Times 3 plus 4 divided by 2, which is 2, times 5 squared minus 5 plus 2. So this is our equation. So I'm going to put a star now that we've finished it. Now we have to go ahead and move on to exponents. So in exponents, we have 2. We have 3 squared, or 3 to the power of 2, and 5 squared, or 5 to the power of 2. So let's go ahead and solve for that. So we get 7 times 3 to the power of 2, which means that 3 is going to be multiplied to itself 2 times, since the number at the right corner is 2. And this is going to be the same for 5 squared. So let's do 7 times 3 squared, which is 3 times 3, so 3 times 3 is 9, times 3 plus 2, again everything stays the same, times 5 squared. Well, we know that 5 squared is just 5 multiplied to itself 2 times, which is 5 times 5. And 5 times 5 is 25. So you get 25 minus 5 plus 2. So now I'm going to put a star next to exponents. Now let's go ahead and move on to multiplication. Now, multiplication, we have these 3 numbers as well as these 2. So let's go ahead and solve one by one. Let's start with these 2. 7 times 9 is 63, and we know that 63 times 3 is 189. Go ahead and try to show work doing 63 times 3. Now let's go ahead and do 2 times 25. Well, we know that 2 times 25 is 50, so we're just going to write that down. So now we have minus 5 plus 2. So what's next? I'm just going to put a star over here, and since we don't have any division, I'm just going to leave it over there. And now let's go ahead and start with addition now. So again, I just want to say that it can be either addition or subtraction. The order doesn't really matter. But in this case, I'm going to solve left to right. So let's go ahead and start with 189 plus 50. Well, we know that 189 plus 50 is 239. So I'm going to write the equation down. And 239 minus 5 is 234. So we get 234 plus 2. And 234 plus 2 is 236. Therefore, 236 is the right answer. If you didn't understand any of these steps, go ahead and rewind the video.
So let's talk about nested parentheses. So what are nested parentheses? Well, they are when there are parentheses within parentheses, which looks like this. Now, in these type of situations, we cannot follow the rule in which we solve from left to right. And what is the order of solving for nested parentheses? Well, first we have to solve for regular parentheses, which, well, you guys already know what regular parentheses looks like. Then you have to solve for square brackets, which looks like this. And last but not least, we have to solve for curved brackets, which look like this. Now, let's go ahead and do an example problem together. 4 plus 3 into 2 minus 1, the whole squared. So, we know that when using PEMDAS, we always have to start with solving for parentheses first. And using this, we know that we have to solve for normal parentheses first. So let's go ahead and do that. So 4 plus, we keep the 3 the same. And what's 2 minus 1? Well, 2 minus 1 is just 1. And the whole squared. The whole squared means that you have to square the whole number that's inside these parentheses. Now, after solving for normal parentheses, let's go ahead and solve for square brackets. Well, how would we do that? Well, you would do that by just multiplying the numbers inside the bracket. So that would be 3 times 1, which is just 3. So the whole squared, meaning that we have to square the whole number. And 3 squared is just 9. So that would be 4 plus 9, which is equal to 13. Okay, now let's do some challenging problems based on order of operations and PEMDAS. Let's do the first one together. Linda bought 3 books for $1 each, 2 pencil cases for $2 each, and 3 boxes of pens for $6 each. She gave the cashier $30. How much money should she get back? Well, let's try to come up with an equation for this. Well, we know that we keep 30 the same since that's what we're subtracting the total cost from. Now, over here it says 3 books for $1 each, meaning that we have to multiply 3 times 1, and we have to put it in parentheses. So, 3 times 1. And it also says 2 pencil cases for $2 each, so we have to multiply 2 by 2. So we also put that in parentheses. And finally, it says 3 boxes of pens for $6 each. So we have to do 3 times 6 and put that in parentheses. Now, we're subtracting the total cost from 30. So we have to add some box brackets or square brackets over here. I like to call them box brackets because we're boxing them. And so let's begin. Now we keep the 30 the same, and then we solve using PEMDAS. PEMDAS says that we have to do parentheses first. So let's solve for this first. And we have to solve for normal parentheses before solving for the square brackets. So let's go ahead and do that. So keep this the same. And 3 times 1 is 3. Plus 2 times 2 is 4. Plus 3 times 6 is 18. Now let's solve for the square brackets. So it's 30 minus 3 plus 4 is 7. 7 plus 18 is 25. So we're solving for 30 minus 25. 30 minus 25 is just 5. So we know that the cashier has to give Linda back $5. Now let's go ahead and solve for the second one. Compute 4 times 58 minus 7 times 4 minus 2. Now we have to use PEMDAS in order to solve. And PEMDAS says that we have to solve for parentheses first. So we keep the 4 the same. I'm going to go switch. And it also says that multiplication has to be done before subtraction. So over here we have to multiply before subtracting it from 58. So that's going to be 58 minus 7 times 4 is 28. Close up the brackets and minus 2. Next, we have to still continue to solve for the parentheses. 58 minus 28 is 30. So we get 4 times 30 minus 2. Once again, we have to solve for multiplication before subtraction. So we have to solve this before subtracting 2 from the product. So let's go ahead and multiply. 30 times 4 is just 120. Now 120 minus 2 is 118. So we get our answer as 118. Yeah. Thanks for watching!
Don't forget to subscribe and like. If you have any questions, you can email info@agoramathcircle.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email but without the info and the end. So bye!